Unit 5, Learning Target 1, determine if a coordinate point is a solution to a system of linear equations. All right, so the first thing we're going to do is we want to define these, so I'm going to talk about it, and then you can pause it and write it down. So a system of linear equations. So what this is saying is, it means two or more linear equations, that's what I say, with the same variables. So it's like two or more lines, so you'll get something where it's like y equals 2x plus 5, or y equals 1/3 x minus 7. You can have 3. They don't necessarily have to be set up as y equals. It could have been like x equals 3/5 y, but they both have a y and an x. They both have the same amount of variables, the same variables in both y and x. So a solution so if you're thinking about it on a graph, if these two intersect, so like here's my graph, and here's the one, and here's the other, right there's their intersection, that point would be the answer, that would be the solution. But if we're thinking of it as like, it could be a coordinate point, x comma y, right? But that's just saying that x equals some number and y equals some number. And both of those numbers should work when you plug them back in for both equations. So when I plug x and y in here, it should give me a true statement. And when I plug x and y in here, it should give me a true statement. If it works for one and not the other, it is not a solution. So pause this, copy it down, and then press play. Okay, so we're going to determine if the set of points is a solution to the system of the linear equation. So we're not graphing this right now, we're just figuring it out. So all we have to do, so like this is my x, so it's telling me, because remember it's always x comma y. So my x is negative 15.6, and my y is 0.2. So I'm just going to plug them in for both and see what I get. So for the first one, I'll do red. So my y is 0.2 equals 47 plus 3 times negative 15.6. So I'm still going to have 0.2 equals 47 plus a negative, okay, 15, this is going to be 46.8. So then I combine these, this one's positive, this one's negative, so I get 0.2 equals 0.2, this one's good. I'm not done, I need to make sure that this one works. I'm going to do this one in blue now. Oh, not that one. I'm going to do this one in blue. So my y is still going to be 0.2 equals, except now I have an 8 plus 0.5 times, what's x? Negative 15.6. 0.2 equals 8 plus half of this is going to be negative 7.8. Combine those. So 8 plus a negative 7.8 is 0.2. So yes, this is a solution. This would be a solution. We're going to do the same thing over here. So here's my red one. This is my x, this is my y. So 2 times negative 4 plus 23 equals 15. Negative 8 plus 23 equals 15. 15 equals 15, this is a good one. Now I'll do blue. So y, so it's going to be now 23 equals 12 plus negative 4. 23 equals 8. This does not work. So since this one doesn't work and that one does, one works and one doesn't, this is not a solution. It has to work for both of them. So this is a no. So all I'm doing, here's my x, here's my y, I'm plugging that in for the first one, then I'm plugging them in for the second one. So my first one. So instead of y equals, I'm going to have 12.3 equals. And then I have 4.5 plus 5. Instead of times x, I'm going to times it by 2. So I'm still going to have 12.3 equals 4.5 plus 10. I'm going to have 12.3 equals 14.5 right away. I know this is going to be a no. It doesn't work here. I don't even need to check that one now. It doesn't work for the first one. That means it's not going to work, so no, it's a no. So this one works because they both give me the same answer. This one did, this one didn't. It's still a no. This one, I can just stop at no. Before class, determine if the set of points is a solution to the sister linear equation. So here's one thing, and you're going to plug this in. So you're going to do exactly like what I just did here. except you're going to try it on your own now.